Hi everyone, welcome to this video. We are at number 10 of the, of the FAM S sample questions. And I think I've said it quite a few times already. These questions are available on the Society of Actuaries website. Okay. The solutions are also given there. You can look up the solutions. But this is question number 10. And we are given, right? You are given a table giving you the number of claims, okay? Giving you the number of claims, the probability of the claim, and you have the claim size and the probability of the claim size, okay? So be careful about the information that is given, okay? It's given in the form of a table, as you can see. So please read it carefully and see what is actually given to you. They tell you that claim sizes are independent, okay? They tell you that the claim sizes are independent, yeah? So they did not say that the number of claims is independent of the size of the claim and so on. So all they've said is the claim sizes are independent, okay? So again, let me remind you, they did not say anything about the number of claims being independent of the size of the claim and so on. All they're saying is the claim sizes are independent. Okay, sorry, I'm going on and on about that. We asked to work out the variance of the aggregate loss, okay? The variance of the aggregate loss. Now, one way you can deal with this is I have shown you a tree diagram. It may help. So you can look at it and take that apart. So first we are talking about you can either have one claim or two claims. Look, I didn't bother about the zero claim. Okay, I didn't bother about the zero claim because it's not going to materially affect my answer, right? Zero multiplied by anything is zero. Okay, so I've got one claim, two claims. Probability will be 3/5 and 1/5. So if you have one claim, it can either be, okay, if you have one claim, it can either be 25 or 150. You can see it here. Okay, and the probabilities being 1/3 and 2/3. So basically the reason I showed you a tree diagram is when you work out the probabilities, which we are going to do shortly, you can just multiply the probabilities along the branches, right? You can take this, multiply by this, multiply by this, and so on. So I wrote this here 25 because that's the amount of the claim, again, because it's one claim, the amount is just 25. One claim, the amount is just 150. Now, if you go to two claims, right? So, okay, two claims, you can either have 50 or 200. So there you go, 50 or 200, the first of the two claims. Then the second of the two claims can be 50 or 200, 50 or 200. Okay, not difficult, right? That's why I thought this tree diagram approach is pretty useful, right? Your first claim can be either be 50 or 200, and your second claim can either be 50 or 200. Okay, so plug in all the probabilities. 2/3, 1/3 is all here. Okay, 2/3, 1/3, 2/3, 1/3. This is 50, this is 200. So 50 and 50, you'll get 100. 50 and 200, you'll get 250. 250, you'll get 250. You can see it here. 200 and 200, you'll get 400. So remember what I told you, right? You just have to multiply the probabilities along the branches and you're set, right? So I've set up a table for you here with all the possible values and the probabilities multiplied out. You can do that slowly. Take a look at my table, yeah? Okay, take a look at my table. And so let me clear the screen. Okay, so I have set up values of X, the possible values of X, as you can see when I talked to you about those values now, okay, on my tree diagram. So the values of possible values of X are 25, 150, 100, 250, and 400. The probabilities, you go along the branches, you multiply out the probabilities. I repeat, you go along the branches, you multiply out the probabilities, and I've shown it to you here again, okay? Okay, I've shown it to you here again, how to get 1/5, 2/5, 4/45, 4/45, and 1/45. I've shown you all the numbers here again. These are the probabilities. And these are the amounts I tried to show you again, okay? 25, 150, 50, and 50, or 50 and 200, 200 and 50, right? Because there are two claims, right? So you can have 50 and 200 or 250. And that's why you have multiplied by 2 here. or you can have 200 and 200. So the same thing that I said on the tree diagram, I have just written it here in the form of numbers, yeah, for you to easily catch on. Once you have a set of values of X and the associated probabilities, you can find the expected value of X. You notice I didn't show any working at all. All you have to do is just take this times this times this, X FX, right? Okay. You can also find the second moments, just square this, multiply by this, square this, multiply by this, square this, multiply by this, and sum it up. Yeah, I've used a calculator for that, and I got these values. You have the second moments and you have the first moments. You can get the variance. Take the second moments minus the first moment squared. You'll get your answer 8100. Okay, answer B. You can also use this idea. Okay, we can also use, if you can also work it differently, right? This problem, you can try it. I have done it, but I am looking, I am not going to post it because the notation, this is my own notation. So I don't know, I can write it for you, the idea, right? You can write it like this, okay? Conditional expectation plus the expected value of your conditional variance. This is how I started my solution, right? Okay, good. Okay, I've written in my other on the other sheet of paper that I have, I've used a different approach. Variance of X equals to the variance of the conditional expectations, expected value of X given N, plus the expected value of a conditional variance. You can also do this and work out the solution, and you'll also get 8100. If you want to see my solution, I can post it up for you to see, but my notation is not really that great because it was working for me for my own personal use. Okay, so you can try this on your own. You'll get the same answer. Okay. Okay. Where once you're done with that, what you can do is you can look at question number 11. I won't be talking about question number 11 anymore because it's a very simple problem. Yeah. Question number 11. You can read the question and see it's a pretty straightforward thing here. Yeah. You're given some data from, some data, and you're told there are 5 ground up claims from a data set that is truncated from below 100. They give you the values. You fit a ground up exponential distribution using MLE, calculate the mean. So I've done the working here for you. Look at it. And the final answer is 73. And so that'll be A. I just gave you the keywords, right? Exponential distribution, yeah, memoryless property, MLE is a sample mean, and you can sort this out yourself. Okay, thank you very much for watching.